Hello everyone. Today we will explore the difference between correlation and causation within cognitive science and why it is crucial for both human intelligence and artificial intelligence. This isn't just an academic debate. It shapes how we understand the mind, how we design AI, and even how we interpret the world. By the end of this talk, you will see why causality is the anchor of reasoning and why correlation alone often leads to mistakes. Think of it as learning to tell apart things that happen together from things that truly cause each other. In the age of big data, this skill is essential because the more patterns we detect, the more likely we are to be misled without causal reasoning. Humans and AI approach reasoning differently. Humans naturally ask why something happens. We look for causes, we evaluate possibilities, and we anticipate what could happen under different conditions. AI, especially modern neural networks, excels at finding patterns and associations, but often doesn't know whether those patterns reflect actual causes. This gap is critical because decisions based on false causality can have real-world consequences. Imagine an AI in healthcare recommending a treatment simply because it's correlated with recovery rates, without understanding if the treatment is the actual reason patients get better. Human reasoning has one of its roots in causality. For example, rain causes people to carry umbrellas, and rain also causes the ground to be wet. We understand that the umbrella itself didn't cause the wet ground, but the rain did. This understanding allows us to prepare, prevent, and adapt in ways purely correlational reasoning cannot. It is the capacity to mentally simulate alternate scenarios, to ask, what if? That gives humans a significant edge in planning and problem solving. AI, especially transformer-based models, operates very differently. They are exceptional at recognizing patterns, for example, linking words together in a sentence or predicting what comes next. But these systems can mistake correlation for causation. That's why AI might appear intelligent in one context, but fail completely when conditions change. When the pattern shifts even slightly, an AI trained on correlations can produce confident but completely wrong answers because it lacks the deeper causal map. This distinction also ties into epistemology, the study of knowledge, learning, and perception. David Bates, professor at UC Berkeley, in History of Natural Intelligence, frames AI development as the externalization of human cognition, what he calls prosthesis. When we design AI, we are essentially trying to project the human capacity for learning and reasoning into machines. But without causality, AI's reasoning remains a sophisticated limitation, not true understanding. In other words, we may be building highly capable pattern machines, but without embedding causal reasoning, they can never fully replicate the depth of human thought. Causality is the anchor that keeps reasoning stable. In both human cognition and AI, causality provides a way to filter out noise, focus attention, and make prediction that hold true across different situations. Without it, patterns drift, and the system, whether human or machine, can be led astray by random coincidences. It is the difference between memorizing a story and understanding the plot that derives it. In practical terms, causality lets us adapt to novel situations because we understand the underlying mechanism rather than just the surface pattern. To conclude, human reasoning is fundamentally cause-based. AI, to truly reach human-like understanding, must integrate causality into its models. Neural networks gives us the power of pattern recognition, and the Bayesian model gives us the structure for probabilistic reasoning. If we combine these with a causal framework, we can move AI closer to genuine comprehension. Ultimately, teaching AI causality isn't just a technical upgrade. It is about aligning machines with the core logic that makes human reasoning so powerful. Thank you.